In astronomy, you're chaotic. You are doing a lot of things in astronomy, like events are going on. Then a lot of research projects you have done, a lot of thesis you have written, like research papers you have written. I saw. Which area of astronomy interests you the most?
Oh, geez. Well, so my area of expertise is in gravitational wave astronomy, which is essentially the ripples in space-time that come from two accelerating very massive objects. So for example, if you have two black holes, which are very dense and very massive, and they're orbiting around each other, then they cause these ripples in the fabric of space-time itself. And so for my PhD work, I studied what sort of models we'd need to use to be able to detect these ripples in space-time using modern detectors such as the LIGO Observatory, which made its first detection in 2015, and that was after I graduated, so it was kind of interesting for that to happen at that point, yeah.
So before we start all this,
Yeah.
let's first of all talk about what is black hole,
Sure.
and what is the fabric, what term you used?
The fabric of space-time.
Fabric of space.
Yeah.
What is that?
Okay, well, so I'll start with black holes.
Okay.
So, because that's a little bit easier. So black holes are objects that are so dense that even light cannot escape from their surface. So you think of like the Earth or something like that, and in order to escape the Earth, you have to be traveling at a certain speed, right? And rocket ships go at that speed so that we can actually escape the Earth's gravity. The more massive an object is, the faster you have to go to escape the gravity of that object. But if you have a black hole, which is this very, very, very massive object, you need to be going faster than the speed of light to escape it. And nothing can go faster than the speed of light. And so that means that even light cannot escape from this object. So usually black holes are due to the collapse of the core of a very massive star after it goes supernova at the end of its life. And so it becomes this just infinitely dense, very compact object, which has this point around it called the event horizon, which is that point at which light cannot escape from the black hole. So the black hole itself, all the mass is contained in like one little point, but you have this region around it that is completely black because no light can escape from it. So we've actually detected black holes, but we can't see them directly, obviously, because light cannot escape from them.
We've used telescopes to detect.
Indirectly. So the most recent image of a black hole is we've taken an image of the black hole at the center of our galaxy, which is called Sagittarius A star. And what you see in this image, you might have seen it in press releases or whatever. It was in the news for a while. It basically just looks like an orange donut with like a black circle in the middle. Yeah. And so that is a black hole's event horizon, is that black circle in the middle. It's the point at which light cannot escape. And then that orange glow around it is matter, which is currently circling around the black hole. So it's spiraling in towards the black hole. It may eventually fall into the black hole, but because it's moving around the black hole very quickly, it gives off a lot of light. And so that's what we're actually detecting. We're not detecting the black hole itself. We've also indirectly detected black holes through X-ray emissions from that same disk of material where all the stuff is getting sped up and you see it glowing very, very brightly. And we've also just seen the effects of the gravity of the black hole. So at the center of our galaxy again, there's this huge supermassive black hole, and we've been able to detect essentially stars orbiting around this empty space. And this was something that won the Nobel Prize a few years ago with Andrea Gheze's team. And it's essentially, you're just seeing like nothingness, like a point in space, and then you have all these stars that are orbiting around that point in space. And so if something has a huge amount of gravity, enough that stars will orbit around it, but does not emit any light, then one has to assume it's a black hole. And we estimate that this black hole is about 4 million times the mass of our sun. So that's a very, very big one.